Okay, so thank you, organizer, for this awesome conference. The first one, in effect, that I've been looking for almost 2 years up to now. And I am Mattia Manzati, for people who don't know me. I am a developer, as is you, and I do a lot of stuff. You can recognize me maybe from a talk that I did at React Alicante, presenting 2 years ago Effect. So I tried to spread the word of Effect 2 years ago, and now here we are together again in order to speak about something else. Today we're going to speak about durable workflows with Effect cluster. So let's start by saying that everyone had to deal with a computation like this at least once in your lifetime. And I'm sure that even today in your production application, you have something like this. Maybe it's not the same domain, but just take it as today's example. So let's see what happens step by step. We call an API and we get the total amount that is due for an order. We charge the credit card for the total amount that is due for that order. Then we create a shipping tracking code for the product we ordered, and then we send a confirmation email with the tracking ID we just created, and also with some thank you email, how information, etc. So here it seems something really simple, right? Well, the problem, as discussed before, is that this is the happy path of the code, but we have to take in consideration a lot of possible failures that are along the way. So what happens here if something fails? Well, Effect is a great tool because it helps us keeping track of all the failures that may happen during our workflows. So we can keep track of domain error, network error, temporary errors, whatever. But what do we do with those errors? Well, maybe just stacking them is not an idea, is not ideal. So eventually we want to do something with that. So let's start very simple and say that we have those errors, and the simplest thing that we can do is just put those errors into some fancy UI for the user. So let's see that this is our code, and let's say that the first call to get total amount works, the charge credit amount works, so we now successfully charge the card of the customer, and now we called create shipping tracking code. But now due, for example, an out-of-quote API of the shipment API, we fail. So what happens now? Will it be clear to the customer that the order has something that needs to be performed in order to actually perform it? Is the computation completed? What do we do? Well, we just learned that in the end, we need to take care of errors because errors are part of the domains and we need to handle them. So there are some kind of those errors that may be, for example, temporary errors due to network. So what we can do maybe to get rid of those errors is just use retries, right? So I am a lead developer, so what I do is that thanks to Effect having a built-in retry option, what I do is just put in the end a retry option and says, okay, if the error is a temporary error like a network error, I will retry the entire workflow, and that's it. But that has its problems. Again, back to our example. Let's say that on the first run, we get the total amount to pay, then we process the payment, and then we fail to create a tracking ID. Okay, retry again the workflow. We get the amount to pay. We charge the credit card. We increase the money that the business does because now we have performed the same thing twice. So the customer surely will be more than happy to pay however you want in order to receive just one goods, right? So, well, that doesn't indeed seem right. So we just learned that also retries are something that we need to handle in a meaningful way for the business. And also, what happens if, for example, we are processing the flow and something happens at machine level and we go on an error and the server restarts? That's another possible error. So, all the kind of the errors that we have described before are just some of the errors, because no matter how you write your code, whatever library you use, or you use a procedural code or whatever, you end up having the same problem. The problem here is that all of the code you wrote had to work and perform everything inside a single process. And so, as I said, what happens if, for example, the server crashes, or we need to restart the server for an update. Well, maybe due to our retries, what we expected to last very few seconds is now taking minutes or hours. So restarting a server will result in basically losing whatever is the state the process was in, and also leaving the system in a dirty state. So people would just say, yeah, well, you just need to put a begin transaction, an end transaction, and that's it, right? Well, the problem is that we do not have a magic begin transaction, commit transaction functions for our code. And that's not a problem of the language. The problem is that we are interacting with different systems, external systems, for example, REST APIs, email, whatever, as those systems receive rights and are not participants of the asset transactions. So it may seem very strange, but this is not actually tied to having an external API to be called. That may also happen when you have something in your internal system. Let's say, for example, that you have a contact form, and in your contact form, you type in your user information, and then you expect that when the submit button is pressed, you save that contact information in a table, and then you send an email. How do you ensure that both of those things happens? Or in the same way, in what can be maybe a local first application, let's say that we have a product catalog, how we ensure that we are storing both the data of the product catalog in a table in an SQLite, and maybe we are storing on the file system the image for the catalog, and how can we ensure that when we delete the product, we delete both of them? Well, we just learned that distributed systems are everywhere. And that means that we need distributed workflows in order to orchestrate distributed system. And sure, there are existing many solutions to handle workflows, but most of them focuses on backend. Most of them focuses on code that's running on a server that's interacting with servers. But as we said before, we can have distributed system even when building local first applications. So that was the idea that convinced me that we need to build cluster workflows. And F cluster workflows provides you all the building blocks you need in order to deal with distributed system. And it provides you all the building blocks using the F semantics. So the F cluster workflows is a system that is built in TypeScript and runs in TypeScript using F. So you can run that wherever you want. You can run that in the browser, you can do that in Electron, on the server, whatever. So one of the concepts that helps shaping up durable workflows of F cluster is the concept of a saga. And the concept of a saga came from a really old paper. Back in the days, they tried to solve a really similar but yet different problem from the one that we are trying to solve. Back in the days, they have this very long computation that would lock on into a database transaction for a lot of minutes. And what happens is that then many smaller transactions cannot perform anything on the database because the transaction of the longer process is locking the entire database. So basically, they were looking for a way to have the same guaranteed of transaction of either executing everything or nothing without actually using a real transaction for the whole process. And the idea they had is really simple. Instead of having a huge transaction along the whole process, you can split it up into many single transactions, and then you can glue those many smaller transactions with some kind of messaging or signaling. And even if we don't actually have database transaction, the same logic applies here for our use case. External invocation through file system or emails or external REST APIs can be considered transactions. So now they also figured out that since we are not using a single transaction, they had the same problem we have as today. What happens if our process crashes due to the server having a problem or we need to restart? We need to have some durable log that basically keep track of the state of the execution, every attempt that has been performed, of every single smaller step of the workflow in order to resume the execution even across server restarts. So let's see how we can implement that using effect cluster workflow. The first building block we want to define is an activity. And an activity can do basically whatever you want. Whatever we said before, you can do things on a database, you can make HTTP calls, you can write on the file system, whatever you want. An activity needs to be identified in some unique way, using a unique string inside the execution of the workflows. And as I said before, behind the scene, there is some kind of persistence, some kind of durable log keeping track of the execution. So that's why you also need to perform schemas for the success and the error type of your activity. And finally, as I said, you provide the body of your activity, which can be whatever you want. Now that we have defined how an activity works, we can move on to real workflow. But before defining a workflow, the thing that we need to do is define a request that is used in order to kick off the execution of the workflow. So the request, in the same case here, should have the error and the success schema for the case. It also has an additional capabilities to the activities that now the request can also have some payloads that can be later used in the actual workflow definition. So that payload you provide is basically the arguments of your workflow function. And now that we have defined our workflow function, we can implement the actual real body. So as you can see, the first thing that we do is we pass in the request that we defined before. The second argument we provide here is a function that, given the request object we provided before with all the details about how we want to start a workflow, is a function that basically creates again a unique identifier for this workflow instance. Okay, and this string can also be used later in order to get information such about if the workflow completed or we need, for example, to interrupt the workflow. And as I said before, a workflow is just a coordinator of multiple activities. We have just broken up. And so, in order to guarantee the workflow has a durable execution, there should be indeed some constraint. One of them is that inside of a workflow, all the steps need to be performed inside an activity. And the other one is that the workflow has to be written in a way that is deterministic. And what does it mean? Well, deterministic means that whatever is the state of the system you are into, you should be always be able to receive the same output, and the output should be always predictable. So, for example, accessing time or reading for the file system or a database, that by default is not predictable, it's not deterministic, because they completely depend on the state of the external system. And so, as we said, the determinism is very important for workflow because, for example, upon a server restart, what happens is that behind the scene, any activity call will be effectively replaced by the successful result of the previous execution that we have in the durable log. Okay? So does it mean that our workflow can perform only deterministic work and nothing else? No. It just means that whatever is not deterministic must be wrapped in an activity. Okay, now we defined a workflow. How do we run it? Very simple. We first spin up a workflow engine, and the workflow engine is the working unit that is basically responsible of keeping track of all the instances of the workflows you are running, and then you use methods such as send or send discard in order to request the beginning of the execution of a workflow. And if you use send discard, you can start the workflow without caring for the result, or you can use instead send and wait for the result. And also, as I said before, the workflow requires some persistence, right? And here the persistence, thanks to effect, is completely pluggable. So here I'm using Postgres, but maybe if I'm writing some local first application, I can use a SQLite storage, or if I am in the browser, I can use whatever I want. Okay, so we said that basically the workflow needs to be deterministic. And that's very important because that's what allows workflow to be restarted. But let's just think about this problem a little. What happens when the workflow engine starts an activity, which is the basic building block of a workflow? Well, the workflow engine has no insight of what is happening inside of the activity. So let's take a real-world example of a problem. Let's say that, again, we have our HTTP payment API. We trigger the HTTP call. The remote server receives the request. Then it processes the request. It successfully processes the request. But just before sending back the response, the network connection drops. So seen by the side of the workflow, it's the same as it never started. It never has been received by the other server. You cannot tell. There is no difference between that. So what will happen is that the workflow will try to perform again the activity. And guess again, we are making business again. We are performing again the same payment twice. Okay, so what's the lesson to learn here? While workflows need to be deterministic, activities needs to be idempotent. So what does idempotent mean? Well, idempotent means that multiple invocation of the same effect should result in a state change only upon the first invocation. And subsequent one should not change the state of the system. So let's try with a real-world example. Let's say that you have an orders table, and inside that orders table, you have a primary key that is auto-increment, and you are performing an insert query. Performing multiple times the same insert query isn't idempotent. No, because I will end up with multiple records in my database. Does performing a delete by primary key on my table an idempotent operation? Yes, because after the first execution, you will not delete everything in the table, but you need to consider that someone else may insert again something with the same primary key. So, how does effect cluster workflow help you with that? A common practice that we have is using idempotency keys. An idempotency key is basically a key that you provide with your request to the remote server in order to let the remote server handle and detect the duplicated request. So the remote server, when he detects a duplicated request, what he does is just basically send again back the response that he did, for example, in the first execution. And effect cluster already helps you by providing you a persistence ID that is deterministic by definition and can be used in order to let you use idempotency keys. So, we said before the workflows usually have activities that are usually retried forever until they either succeed or they fail with some domain problem. And thanks to the activities being idempotent and then workflow being deterministic, we can forget about things like temporary error or timeouts. So does that mean that if for some example we get stuck into some potential infinite retry, we are doomed to have something that we can never stop and never fix? Well, no. Thanks to the activity being idempotent, what we can do is just stop the workflow engine, fix the implementation. Like here, for example, I put wrongly the API secret 2 times, and then when I start again the workflow engine, it will detect and use the new updated activity definition, and then eventually finish the execution of the workflow. So that isn't the best ideal things to do. So effect cluster workflow also provides you what's called yield workflow, yield execution, that basically yields the execution of the workflow, pausing everything, and you can then write it maybe in a developer log sending a bug report saying, okay, I got stuck here, something is wrong, and the workflow will be paused and not tried again until it is manually restarted by the developer that has just fixed the problem. So, for what we said that fixing activity is really easy. What about instead workflows? Well, this is more trickier, but not so much. As we've said before, workflow definition must be deterministic. This means that we can fix running workflows as long as we don't break too much the determinism. So one way to achieve that is, for example, let's say if you have new activities to add to the end of the workflows, there is no problem, because if you have a running workflow that haven't completed yet, and then you restart with a new definition, you are just adding new jobs to do in the end. But if you use, for example, a variable, an activity to store the version of the workflow it started, you can do conditional logic, which is deterministic, in order to switch between the fixes or implementation or changes in how the workflow behave. Also, about our Saga paper we mentioned before, we said that we want to guarantee either all steps are performed or in some way we abort everything. And up to now, we only spoke about workflow using retry to indefinitely succeed and do stuff. But what do we do if we have a failure downstream? Let's say that, for example, we have something like an amount of stock, of product that goes out of stock, but we already charged the credit card. Now we need to do something because we basically received the money, but we cannot provide the product. So we can, for example, process a refund. And how do we do it? Well, we just use the regular Effect APIs, we catch the out-of-stock domain error, and then we can now call the refund credit card method that is also an activity. So what means is that inside cluster workflows, you can use regular effect semantic, but this changes a little because now is intended in a durable way. So you can use all of the Effect APIs in a durable way. And we are guaranteed that either we succeed all or we revert thanks to using what's called compensating actions. Okay, so we have seen how Effect Cluster allowed us to build durable and resistant workflows by using regular Effect code that to some extent just seemed like a regular Effect code. But now we have a problem. We also list a lot of use cases where we need a distributed workflow and maybe a single process is not enough because maybe we are going to starve our single process with all we need to do for all the workflows that are pending in our system. So maybe in order to avoid to starve our process, what we can do is spin up multiple processes, right? So we can fix that. Well, that's worked, but it opens up a new problem. How do we ensure that, for example, the processing of a payment of an order is now running only on a single server and not on two different processes, for example? We need to ensure uniqueness. And well, sure, you can do that by using some global lock, but that won't be performant. That will also add a new central point of failure for your application. So are there alternatives? Well, let's see that in a real world scenario. Let's say that we have a restaurant. The restaurant has 6 tables, and I'm the waiter. I take the order for the 6th table. Now the restaurant owner decides that I am too slow because I have too many tables to follow. And so the restaurant owner decides to introduce a new waiter in order to help me. But now, how does the restaurant owner ensure that every table gets its order taken only once without asking the kitchen every time if the order has already been taken? Where the restaurant owner is really, really smart, and what we does is basically decide up front that the table from round 1 to 3 will go to me, and the table from 4 to 6 will go to Michael. And well, that's it. Now, me and Michael can serve customer without asking each other if the table has already been taken its order, because we know that we have responsibility. And if for some reason, Michael, a factor die, yeah, if for some reason a factor dying, the restaurant owner can just tell me to just bring the orders also for the other table. So he's basically assigning to me the tables. And if for some reason we came back from the zombie apocalypse, now the restaurant owner will again assign the work in order to ensure that every table has a waiter. And this pattern that we have seen in real world is called sharding. And Effect Cluster also includes a sharding and location transparency set of utilities that allows you to build a cluster of servers that share workloads of entities to process. So, cluster sharding, as I said, is all about building entities that live across different processes and communicate with each other, like we mentioned today in the early talk, the actor model, right? So we have entities that communicate together with messages, and they communicate together without knowing where the entity is living. They just communicate it by the mailing queue, which is basically the entity ID. And each time a new participant in the cluster appears or disappears, like here, for example, I'm starting a new process, the shard manager, which is basically the restaurant owner, will assign new work of entities to the new process spawning up. And sharding is actually not tied to the workflow problem. That means that you are free to define your protocol using FX schema, and here's your messaging protocol. And then, after that, you can register into your sharding cluster the behavior for the protocol. So when you receive message of that kind, you, for example, can perform increment, decrement for a counter, or get the current value of the counter. So let's have a quick recap of what we have seen today. So today we have seen FX cluster that helps us solving the sharding problem and distribute work across different processes. We have also seen cluster workflows, which helped us building durable workflows that are resilient to any problem, even machine failures. And these packages are right now in an experimental state. They're going to be published as tomorrow, effectively on NPM. And I invite you to try use them in order to build your application in a more resilient way, in a more durable way. And everyone, thanks for listening and happy effecting.